Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode problem, and the problem's name is find largest value in each tree row. So you are given the root of a binary tree. You have to return array of the largest value in each row. For example, if this tree is being given to you, and let's say the root of this tree particularly is given to you, so what you have to return is maximum in this particular row, then maximum in this particular row, and then maximum in this particular row. Okay, so maximum in this particular row will be 1, in this row it will be 3, and in this row it will be 9. So how you can achieve that? We can do a level order traversal. Basically in level order traversal, what we do is, let's say for a node, instead of going depth wise manner, you first discover its neighbors, discover or explore its neighbors. So let's say you are given root. So starting from root, you are currently having root. So what are its neighbors? 3 and 2. Okay. So initially, let's say 1 is being stored in a queue. So it's nothing but just a BFS, breadth first search. So you will take out 1 and NQ 3 and 2, its neighbors. Okay. So then you are done with one level, and another level is currently in your queue. So then you will explore their neighbors, and when you are done with this level, you will be having another level which will be the neighbors of these two. Okay, similarly you will continue, and I will be also providing a link of article describing what level order traversal is for more clarity. This is just a rough estimate what I have told you. So we will be traversing tree level by level. Tree traversal level by level. And we can just easily keep a variable to store the maximum value that we have encountered for a level. Okay, what we can do is keep a variable to store maximum value at each level. Okay, so without further delay, let's move towards the implementation part. And you may ask what will be the time complexity and space complexity of it. So the time complexity will be number of levels of the tree, number of levels, order of number of levels, and the space complexity will be. So at max in a queue, what can be the space order of the space that will be occupied? So it will be nothing but the width of the tree. Okay, order of width of tree, order of width of tree. Okay, so let's move towards the implementation. So we will be taking a queue to store tree node values. Let's call it level queue. Okay, and what we have to return is we have to return a vector denoting max value in each level. So we will also declare a vector max level value. Okay, so this will store our final result, or this will be the final result that we will be returning, and level q will be it will be used to do level order traversal of that tree. Okay, so initially let's say let's see what are the constraints. So number of nodes, the root can be null also. Okay, in case the root is null, what you have to return is, I think you will return a empty queue, empty max level order array or say vector. So in case your root is null, then you will simply return this max level value. Since you are not having any nodes in the tree, so it will be of no use to populate this particular vector. So in case your node is not null, then you will do the following things. First of all, you will enqueue your root into the queue. So queue dot level order queue dot push and your root value. Then while your level queue is not empty, you will do the following things. This is just a standard level order traversal that I am using. So I will be providing a link for the level order traversal. So level order traversal. So this link will be provided to you. Okay. So you can explore this article and then you will be able to understand how the level order traversal works. So you will be storing the size of the queue that is currently. So level queue dot size. While this size is greater than 0, you will keep popping elements one by one from the queue and exploring their neighbors. Okay, here you are exploring current level nodes and enqueuing their neighbors in the queue. So pardon me if any spelling is incorrect. I hope it does not affect your understanding of the solution. Okay, then what you will do is tree node, current node that is being discovered or say taken out from the queue, level order queue dot front, and then you will pop out that node. So level order queue dot pop. Okay, and then what you will do is you will enqueue its neighbors or say children. So if current node left children is not equal to null, then you will enqueue it into the queue, level order queue dot push current node and its left child. And if its right child is also there and current node right child is not equal to null, then you will do level order queue dot push current node right. Okay, so after doing the following things, at last what you will do is so we will also be storing the max value at each level. So we can declare a variable here to store max value node at current level. Okay, so int max val node, you can, let's see what are the ranges of. So I think minimum integer value can be assigned as of now. Then we will keep updating this value according to the value of current node. So max value node will be updated according to the current value of current node. So max val node. Okay, and then Once you have enqueued his children, then you are done with this particular level once you have exited this loop. So at last you will be enqueuing the adding the maximum value of current level to this max level value vector. Okay. So max level val dot push back max val node. Okay. And then at last you will be returning this vector max level val. So I think this should be it. Let's try to submit it for the sample test cases. Before submitting for final evaluation. Okay, there is some error. We have misspelled the name. Okay, here it will be Q. As you can see, it's getting accepted for the sample test cases. Let's try to submit for final evaluation. So as you can see, it's getting accepted for the final test cases. So this will be our solution. So I will be explaining once again. So what we have done here is this vector will be used to store your final result, maximum values at each level, max values at each level of the tree. Okay, and if let's say your tree is having null as your root, then there is no node in the tree. In that case, you will simply return this max level value vector or say array. Okay, and if that's not the case, then you will do a level order traversal. This is just a standard level order traversal. The only modification here is that you are storing maximum values at each level and then adding that to your resultant vector. Okay, so you can explore this article of level order traversal, and that's pretty much it. If you are still having any doubts, please feel free to ask them in the comment section. I will be more than happy to answer. So thank you for watching. Thanks.